All right, we're taking a look at number 18. Now, a major thing that you want to know is that exponentials and logarithms are inverses of each other. So, for example, if I have 2 to the x, then its inverse function would be log base 2 of x. And inverse functions, they'll undo each other, like adding 3 and subtracting 3, squaring and square rooting, stuff like that. And we learned that when you take a function and compose it with its inverse, right? So like f compose or f of f inverse, right? Or the other way around, that since they undo each other, only x survives in the end. This is something that we've learned about inverse functions. So what that means is consider these two right here. If, since these are inverses, if I were to take f inverse and plug it into f, okay, so if I were to take this and substitute it in right here, what I would get is I would get 2 to the log base 2. Or vice versa. Let's say that I wanted to go the other way with it and I wanted to substitute. See if I can pull that off. Cool. But I wanted to substitute this one in here. So that would be like this case, right? Okay. So then it would be log base 2 of 2 to the x. What you need to recognize is when you do have this function composition going on, okay? When you have substituted a function into the other. So here we have an exponential with a log inside of it, and here we have a log with an exponential inside of it. When you have those cases, they undo each other and just x survives. Because these bases match, these will cancel out and only x will survive according to what is being said here and the fact that we know these are inverses. So that's the big part of this number 18. And I notice it's generating all different kinds. The one I picked right now just so happened to have e and natural log, but I think most of them didn't, because when I looked at it last night, it had log log, right? But what you want to take away from this is that natural log has a base of e. So I'm going to put that base in there. Well, this is the exact scenario we were just talking about where these match, right? Where the bases match on these. So what that implies is that these are going to cancel each other out and we should just be left with b. I want to make sure that you understand that this is because these two functions are inverses and their bases match, right? That's why they're inverses, right? They have to have the same base, but they will cancel each other out, okay? And this is the case of a logarithm substituted into an exponential. You want to check yourself and see if you can tell what's been plugged into what, especially if you're going on to calculus. You want to be able to spot this function composition so that chain rules become easier for you when you do take a calculus. Okay, so my claim is that when you have e to the natural log of x or the natural log of e to the x, in both of those cases, the natural log of e and e to the natural log cancel out and you just get x when all is said and done. All right, let's go put b in for this. It's funny because it's an easy one, but the y isn't easy on this. So make sure you're always thinking about y. Excellent. All right, you guys, hopefully this helps you out with whatever your number 18 is. Take care.